This is our brake pedal project. I'm Cam Jackson Jr.
Barry Coleman.
I Sam Manuel and Cassidy Gilliam.
And this is our project. For the project, we were asked to create a special brake pedal for a racing car. And its main performance criteria is that it must have a yield strength of 25 kilopounds per square inch or higher, and an ultimate tensile strength of 35 kilopounds per square inch or higher.
The background info. Casting is a manufacturing process that involves the following steps: creating molten metal, forming a pattern to be used as a mold, pouring the molten metal into the mold, and allowing it to solidify, and then removing the finished product. Casting is useful for a variety of objects from different ranges from smaller to large objects, including the brake pedal.
For the purpose of this project, we want a material that has good strength and ductility, good fluidity, and can resist the hot tearing, and overall has the castability needed to perform this duty. The material we selected was a B356 aluminum alloy with T6 heat treatment because it has an ultimate tensile strength of 38 kilopounds per square inch, a yield strength of 30 kilopounds per square inch, fulfilling the criteria we were given.
Casting processes. The project limits us to 3 certain kinds of casting methods. You have sand casting, investment casting, and die casting. Sand casting, you have the pattern of cast in sand that's used to imprint it. You fill the mold cavity with molten metal, you let it cool to solidify, and then you break the sand mold, and then you remove the casting. With investment casting, it's made out of wax and coated refractory material. So once the mold is dried, it's heated to melt out the wax, and then it's poured and solidified. The mold is broken throughout the shakeout, and the casting is removed. With die casting, it's characterized by forcing molten metal under high pressure into a mold cavity. The mold cavity is created using 2 hardened tool steel dies, which have been machined into shape and work similarly to an injection mold during the process. It's also economical for large production runs, such as making a whole bunch of brake pedals. Metals can be forced in the die cavity at pressures from 20 to 7 megapascals and even up to 150 megapascals if necessary. Being that we are using aluminum, we're doing a cold chamber process. This is good because it's rapid production of high quality of parts with complex shapes, such as the brake pedal. Also, with the mold that the core and with the round corners to reduce the stress concentrations, is good for dimensional accuracy and surface detail and finish. So the kind of mold that we're using is a single cavity die, where you use high pressure to simply force the mold and make the product. With the mold design, you reduce or avoid isolated thick sections. Also, you got to be considerate of the pivot holes. Within the mold, we have one big square rectangular section, and next to it is 3 other holes that's included within the mold. Also, I already told you it was forced into the die cavity and was pressed with high pressures. So that's how the mold design and the mold cavity is made.
Discussion and conclusion. For the post-casting procedures, the reaming operations will be used to better surface finish for the holes, the pivot hole and the 3 holes that's to the right of it. And the T6 heat treatment will be used to give the brake pedal the desired properties such as ductility, strength, and all the above. Milling, to be specific, end milling will be used to make the hollow section of the brake pad, which is the indentation part on the right side of the brake pedal. And this is our brake pedal project. The